Okay guys, so tonight I will show you how to run a PWMK test, which is a pre-whitening modified Mann-Kendall test. So this is another version of pre-whitening method for type of variation of modified Mann-Kendall. So they do pre-whitening first for modified Mann-Kendall test. So it's quite similar with another test that do pre-whitening, but this is another version of it. Pre-whitening Mann-Kendall test. So this is designed to train for trend detection in time series data, which is usually we do for climate data, especially when data exhibit autocorrelation. So maybe in your study you can do a autocorrelation test first for your time series, and if there is autocorrelation, then you need to run this. You need to do a pre-whitening for that data set first by using PWMK, and then run the PWMK trend test so that the data will be pre-whitened first. Clean the data from the autocorrelation first. So this will address the effect of autocorrelation based on the traditional Mann-Kendall test. So that is why we have the PWMK pre-whitening test. So let me share the screen for the code for this one. So yeah, this is the code how to run the PWMK test pre-whitening modified version of Mann-Kendall in R. So we use the same library, which is modified MK library. We run this library first, and then we set our working directory where we put our data set. This is folder address, and then we read our data, CSV data set. So the data set is this. Plus this one first. This is the CSDI extreme temperature dataset, which is from 1950 to 2022. So we have year, month, and then all 28 column of our data here. So from column 3 until column 30. So we have 28 grid point, and we will run all this PWMK test for each of these grid point, each of this time series. So we have from 1950 to 2022. Right? Just now we will run trend analysis by using PWMK. So now we already read our CSV file. Now we read the column, which column we want to read, which is from column 3 until 28 just now, 3 until, and call that. That's mean it will read column 3 until all the column. And then we get the result, create empty data. When we want to do this PWMK test, you see we have down here perform PWMK test by using PWMK function by using from modify MK library. So from this PWMK function, we run this test, PWMK test, we will get certain value that we need to extract from the dataset from the output, which is column Z value, send slope, all send slope, P value S, val S, tau, and also we will do a trend label so that we know which result is positively significantly positive or negative. And then you need to do this create empty data frame first to store the result. So result for data frame we have this column for integer, and then Z value send slope is all numeric until trend label is also character. So we hit the numeric length for column to analyze. This is the empty data frame that you need to prepare first, and then we perform the PWMK test. So for I in sequence along column to analyze, we get the column to analyze result for this is the function for modify MK test, which we run pre-whitening modify Mann-Kendall. So the result we will get the column corresponding for all the empty data frame just now. You get the column from call, Z value from result. Here we extract the result from PWMK just now. They have many result, many layer of result. We extract here 1, 2, 3, 4, 5, 6, and 7, which is a send slope, which is all send slope, P value, S, vals, and tau. And then now we determine the trend label for significant based on 0.05, which is a 5% significant level. So if result for the P value is less than 0.05, we will get the result is positive or negative. If there is no trend, then this will be empty. We will not give any label. And then we extract this result for PWMK. Let's see for CSDI. Now we run this data frame, and then we perform our PWMK test. So we perform our PWMK test. So after you see it's very fast. So PWMK test, now we get the result. So we can extract it. trend PWMK CSDI. So trend PWMK CSDI. So we get all of this result. You see, this is all the empty data frame and the heading that we call prepare just now. Now we have our result when we run. So since slope, this is all the zero because the value is very small, 0.000 point something like that. So that's why it's show you a zero value here. And then we have p value, s, vars, tau, and then trend number. You see there is no trend here. That means there is no significant trend for CSDI based on this PWMK test. So no trend, no positive trend or no negative trend. So but we can change the dataset by using, maybe we can check for DTR here, because I have a dataset for DTR also here, which is similar dataset but different value for DTR. We can run this one and see the result. Let's see for this DTR PWMK. So we can run this, the whole code again. And because it's quite fast, so we can redo this code. See, it's running everything. Now we have trend PWMK for DTR here. This is the new output. So okay, the same result, the same arrangement of result. This difference you see, this one we have sense slope and all sense slope value because the value is there. The value is there. It's not very small, so we can get it. So it's not zero. So just now the sense slope is zero because it doesn't have any significant trend, right? So then now we have this trend level. It show for DTR at some grid point, so positive significant trend for 5% significant level. If you want to change the significant level, you can change it here for 10% or 20%. It's up to you, but usually people do for 5% significant level. So this is the result. We have 1, 2, 3, 4, 5, 6, 7, 7, 8, 7 grid points that show positive significant trend for DTR. So yeah, this is very easy for you to get the result, right? You need just understand, is there positive or negative trend. So this code is there for you to help you to get all of this result for PWMK trend test, modify Mann-Kendall test. So I hope this tutorial will be helpful for you. Okay, thank you for watching.